Hello everyone, my name is Iman Yahya and my colleagues and I are going to represent you Kotlin programming language. We are going to discuss what is Kotlin and the architecture of Kotlin and how is Kotlin different from Java and the concurrency in Kotlin and some features, detailed features in Kotlin. And then we have written a code that we are going to discuss with you and the latest version in Kotlin and the upcoming version and common applications of Kotlin and the companies that use Kotlin, and finally and not least some challenges that we have faced while coding in Kotlin. So let's start. Firstly, what is Kotlin? Kotlin is a programming language that was created by JetBrains in 2011. It was designed to interoperate with both Java and Java Virtual Machine. It is known for multi-paradigm language, and in addition to it is known for Android development, and in 2019, Google announced that Kotlin programming language is now its preferred language for Android app development. In this slide, I'm going to discuss architecture in Kotlin. Most programming languages have their own architecture, and Kotlin has its own architecture design to allocate memory and produce a quality output to the end users. And this is done through two different scenarios. The first scenario, when the code is targeting Java. So Kotlin compiler creates a bytecode, and that bytecode can run on top of Java Virtual Machine, which is exactly equal to the bytecode generated by java.class file. Whenever two byte-coded files run on Java Virtual Machine, they can communicate with each other, and this is how an interoperability feature is established in Kotlin for Java. And our second scenario is when we have JavaScript. So whenever Kotlin targets JavaScript, the Kotlin compiler converts the .kt file into ES5.1 and generates a compatible code for JavaScript. Concurrency in Kotlin. Kotlin runtime does not use classical thread-oriented concurrency model because it is known to be error-prone and unreliable. Instead, it had different approaches. One of these approaches is called coroutine. Coroutines are like threads executing work concurrently. However, coroutines are not necessarily associated with any particular thread. A coroutine can initiate its execution on one thread, then suspend and continue its execution on a different thread. While a coroutine is suspended, it does not block the thread it was running on. When a coroutine reaches a suspension point, the thread is returned back to its pool, so it can be used by another coroutine or by another process. When the suspension is over, the coroutine resumes on a free thread in the pool. And coroutine is not the operating system. It is only a feature in Kotlin. And as I mentioned before, we have different approaches that I didn't discuss in this slide. Mayor will get back to coroutines in feature section, but she will be discussing it in a different angle. So in this slide, I'm going to discuss how Kotlin can replace Java. So first reason is security. Kotlin is more secure than Java, mainly due to two main features. First feature is null safety. Second feature is emphasis on immutability. And we have a section called features in this video, and we are going to discuss in more details about both features. Second reason is interoperability. That means that Kotlin is designed with Java interoperability in mind. Existing Java code can be called from Kotlin in a natural way, and vice versa. That means that you can run a code from Kotlin on Java and vice versa, Java on Kotlin, using a feature called interoperability. Third reason is that Kotlin is an open source, so programmers have the ability to access libraries and some codes from online. Fourth reason is syntax. Kotlin syntax is more compact than in Java. And finally, that Kotlin is easy to learn because Java and Kotlin have similar syntax and similar language. However, they are slightly different. So it is easy for those who learned already Java to transfer to Kotlin, and those who want to learn about Kotlin. Kotlin is an open source, so it is easy for them to learn about Kotlin. So now I'm going to leave the floor for Jacqueline and Mayar to discuss some features in Kotlin.
Hi, I'm Jacqueline. So now Mayar and I are going to elaborate on some of these major features Imane just mentioned. These features we think are both important and distinctive. One of Kotlin's great features is the use of extensions, which are special declarations that allow us to add new functionalities to existing classes without having to inherit from the class. For example, we can write a new function to an existing class or even to library classes using what is called extension functions. When we define an extension, we don't actually modify the class we extend, which means that the new members are not inserted into the class itself. Rather, we just make new functions that become callable using the dot notation on variables of this type. A very important note is that extension functions are dispatched statically. This means that extension function being executed depends on the type of the expression on which the function is invoked, not the type of the result of evaluating that expression at runtime. Kotlin also has modern features, like high-order functions, lambdas, and anonymous functions. High-order functions can take functions as parameters or return a function. Kotlin functions are called first class, which means that they can be passed as parameters to functions, they can be returned from high-order functions, and they can be stored in variables and data structures. Kotlin actually has a family of function types, which includes the lambda expressions and anonymous functions. Lambda expressions and anonymous functions are called function literals, which means that these functions are not declared but get passed immediately as an expression, like the example below. Here, function max is a high-order function, and it takes a function value as the second argument. Kotlin lambda have very similar syntax to Java lambdas, and they are considered anonymous functions. Anonymous functions are similar to normal functions, but they're declared with no name. In Kotlin, high-order functions and lambda expressions are stored as objects. Thus, memory allocations for function objects and classes, as well as virtual calls, create runtime overhead. In order to reduce or even eliminate this memory overhead, we can use the inline modifier, which basically requests the compiler to simply copy the inline code of the function at the call site instead of allocating memory for it. The inline modifier will cause both the function itself and the lambdas passed to it to be inlined into the call site. Although inlining may increase the size of the generated code because the functions are being copied, it will increase performance if we avoid inlining large functions. So now I'll talk about null safety. The danger of null references, what is commonly known as the billion-dollar mistake, is something that Kotlin aimed to eliminate from the code. The problem with many programming languages, including Java, is that accessing a member of a null reference will result in a null reference exception. So what Kotlin does is it distinguishes between references that can hold nullable references and those that cannot. For example, a regular string variable cannot hold null, as you can see in the example below. And if I do want it to hold a null value, I can just add a question mark at the variable type declaration, like the example below. This way, it is guaranteed that if I call a method or access a property on A, it will not cause a null pointer exception. However, if I try to access the same property on B, I would get a compiler error saying variable B could be null. Another great feature about Kotlin is SmartCast. In Kotlin, we can check whether an object conforms to a given type at runtime by using the is operator, like the example below. In many cases, explicit cast operators are not needed in Kotlin because the compiler tracks the is checks and inserts safecast automatically when needed. So for example, if we declare a variable x and we don't give it a type, and then we say if x is a string and it evaluates to true, then x will automatically be cast to a string. Similarly, we can use the negated form of the is operator and check if a variable is not a certain type. And the compiler is actually smart enough to safecast a variable if the negated form leads to a return, like the example below. It is important to note that smart-casts only work when the compiler can guarantee that the variable will not change between the check and the usage. Immutability is another one of Kotlin's great features. It implies that an object or variable once created cannot be changed. Kotlin Native, a technology for compiling Kotlin code without a virtual machine, implements strict mutability checks, ensuring that the object is either immutable or it can only be accessed from the single thread. Immutability is a runtime property in Kotlin Native and can be applied to any object using the function kotlin.native.concurrent.freeze. It makes all the objects reachable from the given one immutable. However, once the object becomes immutable, it cannot go back. One of the greatest benefits of immutability is it's thread safe, and objects like Kotlin strings and other primitive types are naturally immutable. So now Mayar is going to continue discussing the rest of Kotlin's major features.
This is Maya Rodi speaking. Moving on to the next feature, I'll be talking about type inference. Type inference for variable and property types. Now, what is type inference? Type inference is the automatic detection of the data type of any expression. It can be initializing a parameter or a variable. It can be determining a function return type. For Kotlin, the compiler implicitly infers the type of constant. So if the user doesn't explicitly state the type, the compiler will implicitly infer the type of constant. In some cases, this can cause a problem because unintended types can be inferred. The next property of interest is the singletons. Now, a singleton is a pattern that ensures thread safety by allowing the creation of only one instance of the class. This restricts the instantiation of the class, and a global point of access is given to this instance by the singleton class. Now, a singleton class can be invoked outside the class declaration to create a singleton object. So when it comes to creating a singleton object, the user can either create it inside the singleton class, or the user can create it outside the singleton class in another class, but not an inner class, or the singleton object can be created completely independently or declared completely independently outside any class. The most important thing is that the singleton class keyword has to be used in both cases when the singleton object is not declared inside the singleton class. The object doesn't have a constructor, and it is instantiated when called for the first time. When it comes to companion objects, a singleton class can implement a companion object. Actually, every class can implement a companion object. So what is a companion object? A companion object is used when one wants a function or a member of an object to be accessed by the class name only. So this object is common to all instances of the class that it was created in, whether it was private or public. The object is not instantiated until it is called for the first time. The next feature is completely different. It is range expressions. Now, a range is an interval that has a start and an end value that can be defined. It is most commonly used to check whether a certain value fits the range or not. The two dots operator is used between the two values to specify the range, and the range can be assigned to a variable, or it can be used separately for comparison purposes. The ranges can be altered in several ways using different features such as the step function, the down to function, and the until function. These are just three ways or three examples of ways the range expressions can be manipulated. Mostly, range expressions are used for numbers, but they're also sometimes used for letters. So the range can be from A to Z, or from 1 to 10. Finally, the last property we're going to highlight today is coroutines. Coroutines can be used on languages like Android with multi-threaded programming paradigm. It is a concurrency design pattern used for parts of the code that doesn't work concurrently. Now, the main use of this feature is when too many tasks are being performed on the main thread. This can cause the application to start slowing down or even freeze. What coroutines do is that they use a suspend operation in order to pause carrying out a certain task until the other ones are completed. All local variables in the current stack frame are copied from the main thread and saved until the completion of the previous task. The stack frame matches the function with the correct local variables, and after that everything is copied back to its original place and the execution is resumed using the resume operation. Coroutines are implemented on regular functions, so it doesn't have to be a special functions in order to implement the coroutines. Now I'll leave the floor to my colleague Ahmed.
So, in this part of the presentation, we're just gonna be explaining the code that we have written in the language Kotlin, and we'll try to do this in as much detail as we can. So, first, there's a concept that needs to be discussed when it comes to languages that are used in mobile applications, and in specific, in this case, it's Kotlin that is used in Android mobile applications, which is a certain design pattern, and that is the model view controller design pattern. So, the special thing about this design pattern is that even if you create a console application, it pretty much mimics the steps that you're going to be going through when creating an actual mobile application. So this design pattern is basically consistent of a view class, a controller class, and a model class. The model class is the one that contains all the logic, and in a large case, like an actual application, it would be connected to something like a database or something like that. With the view, it is the one that is mainly focused on user interactions. So the view class would have things like printing on the screen and receiving user input. And then there's the controller that connects both classes, and it takes care of things like how a certain user interaction would affect the model and the other way around. So, what did we create? We created a tic-tac-toe game. And the level of intelligence that we reached within this game is that the computer is smart enough to detect cases in which it's about to win and tries to go for these. If it doesn't find any, it tries to detect cases in which the user is about to win and it goes for these. And if it doesn't find any of the two mentioned cases, it just plays in any random place. However, the computer is not smart enough to make predictions on moves that the user can do in order to make themselves win. So, again, if there's no clear chances of itself winning or the user winning, it just plays in a random place. So, let's move to the logic of the game. Basically, as we mentioned, it follows the MVC design pattern. So let's start by the controller, which is the class that connects both the view and the model. At the very beginning, there's a function within the controller that it's called play. That's the one that is called in the main function when an object of the controller class is created. And in this function, an object of the model class and an object of the view class are both created. And then it moves to a for loop. The purpose of this for loop, which repeats itself 5 times, is that whenever it's that the fact within an XO game, a user can make just a maximum of 5 moves before reaching the win or the draw state. Then there's a do while loop. The purpose of that calls the functions that allow the user to input values for the field in which he wants to play. The fact that it's a do while loop is just done to allow the user to repeat inputting until he puts an input that is valid. And then these inputs that the user has inserted using the view class are stored in the board in the object that was created from the model class, which clearly demonstrates how the controller class is actually acting as a bridge between both the model class and the view class. And then it's the turn for the computer to play. So there's a series of if statements. These if statements check the chances of the computer to win and the chances of the user to win, and lets the computer make its move accordingly. And finally, after each time that the user or the computer plays, the board gets printed. Moving on to the view class. The view class, again, within the MVC design pattern, is the one that is responsible for user interactions. This is why it contains a few functions that are responsible for doing two things. First, allowing the user to input indexes for the cells within the board in which the user wants to play. And it also contains a function that prints the entire board. Again, these are the functions that are called within the controller class in order to, again, to allow to the user to make a move or print the board after the user makes his move or after the computer makes its move. So, moving on to the model class. The model class is simply the class in which, again, the logic of the game itself is there and is the one that holds the data that is related to the game. So the only piece of data that we have is a variable that's called board, and it's a 2D array that holds the value, whether X, O, or null, that is contained within each of the fields of the board. It also has the few functions that are responsible for editing the board itself. These are set cell, make random move, user can win, which allows the computer to make a certain move within a certain place if it's sure that if it does that to stop the user from winning. It has also a function that checks the score, and it has the function computer can win, which again lets the computer make a certain move if it will make it win. And there's get board cell, which returns the value, whether X, O, or null, of a certain field within the board. And now, a few of these functions are going to be explained in full detail, but not all of them, because pretty much they all follow the same logic, but for some of them have a certain purpose. That's why the end goal of the function would be different. However, they all follow the same logic. Let's look at a few functions within the model class. First, there's a function called setCell, which receives basically two integers, and it sets the certain cell within the board with the value X. And then there's a function that's called make random move. This function includes a do while loop that keeps on repeating itself, looking for any random place within the board that is not contained with the values X or O, and then it sets that value with the value O. Then there is the function user can win, which is very similar in logic to the function computer can win. Therefore, we're not going to be wasting time on explaining both functions. They pretty much do the same thing, except for the fact that one of them looks for cases in which the computer can win, and the other one looks for cases in which the user can win. So, speaking of the function user can win, it's a Boolean function that returns true whenever a place that the computer needs to play in order to stop the user from winning is found. And it also allows the computer to make the move, which is by placing the value O within the cell that is going to stop the user from winning. So how does this work? It contains a few if statements and a few for loops that are responsible for looking for cases. What are these cases? These cases are lines, whether horizontal, diagonal, or vertical, that contain two X's and an empty cell. Whenever this case is found, an O is placed within the empty cell and the value true is returned. Finally, there is the function checkScore. The purpose of this function is to check whether the user or the computer won. Therefore, this function is called within the controller class every time either the user or the computer makes a move. Within this function, it looks in our 2D array using if statements for certain cases. These cases are either a vertical, horizontal, or a diagonal line having all X's or all O's. If any of these cases is met, it returns the value true to let the controller know that actually one of the either the user or the computer has won, and it also prints to the screen the result, either user won or computer won.
I am Omar Ad-Darawi, and I will be continuing by talking about the latest version of Kotlin, and that is Kotlin 1.3.72 and the new features that it provides and supports. So first, it has introduced Kotlin Native, and Kotlin Native is basically a technology for compiling Kotlin code where virtual machines are no longer needed, and so it needs basically even less of an environment to help its code run, and it can be simply run on the desktop and create programs on the desktop. Now moving on, there are also many different code features that this new Kotlin provides, and that is unsigned integers, inline classes, which basically overcome the shortcomings of conventional wrappers around some types. There is a parameterless main, and so it's not int main, it's just parameterless. And finally, contracts, which allow a function to explicitly describe its behavior in a way which is understood by the compiler. It is additionally enhanced its multi-platform functions or projects, and this would add a sense of machinability and improve upon its machinability. And finally, it includes a progressive compiler mode, which is completely new, and this is explicitly called to fix some language semantics immediately. So for instance, if you run a Kotlin 1.2 code and you're in progressive compiler mode, it will automatically fix the semantics to adapt to Kotlin 1.3 changes. Now focusing on the upcoming version of Kotlin 1.4, and this is expected to provide several changes and enhances. Of these are better type inference, where a faster, stronger type inference algorithm is going to be used. There are some language changes that will be allowed. For instance, trailing commas will now be allowed, so several commas can be written at the end of a statement. Break and continue will now be allowed when using when inside the when feature. There is no plugin now for Android Studio, which allows running, testing, and debugging of Kotlin on iOS devices. So for instance, you can now plug in your iPhone into your laptop, which is running Android Studio, and test the applications using that device. And finally, the speed of Kotlin native programs should in fact increase. Now looking at common applications of Kotlin, we can identify 4 basic common applications. The first one is Android development, and Kotlin is fully supported for Android development, and it fully operates with Java and Java Virtual Machine, and so it allows it to be perfect for any Android application development. Kotlin is also used on server-side development. It's growing in fintech and banking industries. It's also growing in Amazon Web Services, Google Cloud Platform, etc. Kotlin is also being used in web development. So any Java web application can now be used with Kotlin and using the Kotlin language. It could also be used as front-end language instead of JavaScript, so not just back-end, but front-end as well, which allows Kotlin web applications to be both back-end and front-end by the same language, which could be very convenient. And finally, Kotlin is used in desktop development, and graphical user interface applications seem to prefer Kotlin over other languages, and Kotlin can now produce standalone applications such as the calculator, etc. Kotlin is used by a number of companies in a number of industries. Of these are Amazon and Google, JP Morgan and Goldman Sachs, Pinterest, Netflix, Trello, and Foursquare. However, there are some shortcomings of Kotlin. So the first and most prominent one is the learning curve. There is time and training that has to be dedicated to learning a new programming language, even though it is similar to Java. There is also fluctuating compilation speed. So it is said that Kotlin is faster in incremental builds, but it's slower than Java in clean builds. Moving on to the community of Kotlin, it has a very small community, and so that means that it's smaller developer community for assistance. It's basically harder to find a Kotlin expert when you need one. And finally, there are many keywords, and this can cause difficulty in debugging other developers' codes if they use a keyword that you are unfamiliar with, and so that would add again time to this process. Finally, as we tested Kotlin, we found several challenges. Now, the most salient of these is the many different keywords. There were contracts, finally, transient, and several other keywords that we had never seen before, and so this required us to learn these from scratch. Searching online forums, this was not easy at all, because even though we did find several online forums talking about the challenges we faced in Kotlin, they were more general answers than specific answers to the question that we were seeking. And finally, the concise syntax. The syntax was very concise, which of course has its pros, but when we would look back at our code, we would find that it's very short, and so we would forget actually what this small piece of code meant, and then we would have to again go back and search for what those keywords meant. Hence, we could see the many pros and cons of Kotlin. We do actually believe that the pros outweigh the cons, despite the challenges faced that we have just discussed.
To conclude, Kotlin is a programming language that was invented in 2011, and it was announced by Google to be top for Android development, and it is one of the top programming language nowadays. So we encourage you to explore more about Kotlin and start learning Kotlin language. Thank you for listening to us, and we wish you a wonderful day. Thank you.